So good morning everyone. This is Dinesh Har, who is going to present on behalf of Excel Design Technologies. And the topic which you are going to discuss today is all about your sheet metal features we do have inside the BricsCAD Mechanical model set. So as you all know about that, BricsCAD is a single platform application consisting of all the model set from 2D drafting to mechanical design and build. So in mechanical design, we have the capabilities of creating the sheet metal and also the assemblies, piping and tubing, etc. So we'll explore the basics of sheet metal features like creating the flanges and the edge flanges and editing its properties. So we'll just explore those today, and we can end up with flattening of the sheet metal which we are creating. So I'll just select the default template which is available over there, and I'll just proceed with drawing a rectangle. So after creating the rectangle, hope you can see that it has been not clearly visible. I will just switch off the grid and to make it more visible through your screen. And on the top, we have the quick access bar, and to the tab, we have the 2D draftings which we have used initially to create the 2D draftings and annotations, and modeling to create the 3D modeling features, and surface for creating the surface features. And the next comes the sheet metal, which we can make use to create the flanges which we are going to see in this particular class. So I'm just select on the base flange, or you can use the SM flange base command to create a basic flange or a startup flange for this particular sheet metal. I'll just click on the default value which I have given, and you can make use of the RQ assistant to bridge in a neutral axis. So you can see that there is a change of color to a gray, which indicates that you are in particularly in a sheet metal module of this particular mechanical. So as you can see that I'll just start with the edge flange creation by clicking on its edge, and the next it's on for the angle, length, radius and the taper angle. Here I will just start with the length by giving it as 13 mm, and the angle, which let it be 90-degree perpendicular, and you can see that bend radius has been denoted by yellow color with the green at the top. So this is the denotation that you are can see that you are in sheet metal and not in a 3D modeling phase. You can also make use of the quad menu to create the flanges, or you can use the SM flange edge to create the. You can see that. HM flash. Just clicking on the outer edge which I needed to create, and I will select the partial flange for this particular edge flange. I'll just select the width where I wanted to create. So you can see that we have created a partial flange instead of a full flange, and we can also give its overall length, which is, I will mention it as around 66, and let the angle to be the same perpendicular one to the base flange. So you can see that we have created a two corner flanges, and you can observe that in the mechanical browser we can alter its properties like bend radius, bend ratio and the thickness. For example, I just make change in the thickness. You can see that there is a change of thickness in its window. So just by doing this we can alter the properties of the mechanical sheet metal which you have created. So which is a very unique tool in 2D format you can see in the market. And I just wanted to mention and also create some other flange behaviors which you can see over here. I'll just select this. Just before that, I'll just create another edge flange over here. Make use of the phase prioritization command and select this particular data set, and you can see that the behavior of the sheet metal flange feature, as if we can move try to move the flange, the thickness remains the same, properties remain the same, just the flange is getting edited. So thus by it makes more easier for any other sheet metal companies to work on this labeling. And I just wanted to create another two flange with a more effective method. I'll just select the two flanges at the same time. I'll just make prioritize of the edge selection, and also the another edge which I wanted to create the flanger. And we'll create another vertical flange by selecting both the edges simultaneously. I'll just click on the length and create. So here hope you can see that we have created the four flanges in a matter of seconds. So thus by enabling the our sheet metal a more unique one, and as most possible output that anyone have to see in this particular sheet metal feature is unfolding and getting its blank size and width. So we can make use of our unfold blank size. I'll just select the feature, and you can see that, and I'll just save it in the save 2D format. So thus by we have obtained the blank size of 183/74. This would be more useful when you are doing any sheet metal cutting operations using your laser cut or any other formal methods. So this is all we saw inside the BricsCAD Mechanical sheet metal, where we created the base flange, and we can edit its thickness through our mechanical browser, and we have also changed its contour edge flange thicknesses, and we have created the 2D geometry of blank size and width, which is more essential for any sheet metal companies to do so. So this is all from my end on sheet metal mechanical, sheet metal BricsCAD Mechanical, and we can see about what the other things like inserting the holes and inserting the slots, and what are the other features we do have inside the sheet metal that will be showcased in the next class. So up till then, thanks, and yeah, up till then, thanks for this opportunity. And this is Dinesh signing off. So until then, this is Dinesh R signing off from this class. So thanks and meet you in the next session.